Like I know you have to do from the radius too.
Yeah.
But I
So
think
what
that's how-
happens when the light comes and passes through the radius
What
and
do you-
hits the mirror?
You do from the guy or whoever's the object, like the top of the object, and it'd go from that to the mirror and back and never just stop.
So it's just reflected exactly on the path that it came from if it passes through the radius, right? And Josh, what's the other rule about if it passes through the focal point? So if it goes,
Oh, here it is. A light beam traveling through the focal point before hitting the concave. That one.
yes.
It says.
Starts with the H.
Horizontal.
Yep. If it passes.
I saw
look,
horizontally like
here,
5 times.
from the object through the focus, hits the mirror, it is reflected horizontally. So where is my image going to appear? It's pretty obvious in this drawing. They all intersect here, somewhere like that. So is this object going to be upright or inverted?
Inverted.
And is it going to be real or virtual?
Real.
Real. And you know that because the lines actually intersected for real.
Wait, so how
Okay.
does that work? I mean,
And
if
it'll be
you
magnified. 'Cause
you'd
it's
still
bigger.
see it like it was behind the mirror, wouldn't you? Because you're looking in the mirror.
Yes, and I want to try to figure that out next week with a real mirror. I want to see if we can get one of these.
That's just confusing. Like
Yeah.
the light, I don't know. Like in the virtual image, you see it going, the image appearing behind the mirror, but this one is in front of the mirror. So,
So it's a real image, like floating in midair. Like,
but
Like,
you wouldn't see it floating in midair, would you?
Whoa, that's
Really?
so cool.
that's what it's saying should happen. We
Is
just
it
have
like
to
when you
actually
see
do it.
lasers, like you
The
know,
what, like a hologram sort of?
no, like the ones that
It's like floating. Yeah.
spies go through, and they like go through the air.
What?
It'd be like that if they were off a magnifying glass.
I have no idea, but
I'm sorry.
they, like,
the
have to go,
spies,
like-
they like weave the way through laser lights because they're gonna die.
oh no, that's just so they're not stepping on.
Yeah, but they
them to
see
set up the
them
trap.
in the air. Is it sort of like that? How you see them?
Oh,
in the
how
air?
you see them in the air? There has to be something moving to see the laser beam in the air, because like you can't.
Like,
Like,
if it was
'cause
really
sometimes
dusty.
you do see like laser lights. Sometimes like in the
Like
air.
at night.
dust though.
It would have to be dusty, yeah. Really, really
man.
dusty.
Not necessary.
You can see them if it's not. Well,
My brother had this laser pointer. It was about that long. It was green. You could see it no matter.
you can see it all the way through the air. Huh.
Like you put it like go
What?
outside.
You could
So
point it in
it's-
a house outside. It's
How
usually-
dangerous was it?
Probably pretty.
I don't know.
It's always good to know, but you
It was
know.
nice. It was a really cool color though.
I want one. We need one of those for next year.
Does it burn
Once we
your
get
hand?
our experiments squared away here. Okay, so when you do the test, make sure that you do use a compass, because
No.
the drawings just
It was
don't
a
work
legit-
if you don't.
If
So
you
if I'd
don't,
like
it's
to
gonna look
draw
like
the
a bunch of
second
squiggles.
one, Christina.
No, I was not volunteering.
Yes, you were, but
No, I was just wondering.
Oh,
like,
it's just spark.
smoking.
Can
Oh,
we put a
good.
bug in this thing?
Not when I'm watching. If you wander off while I'm packing my car and you give it back when you're done, whatever. And you clean it out. Yes, seriously.
Fly like
You can't find the bug.
Okay, what?
Okay, I was just wondering, like, how big does the angle have
This
to be?
depends.
Yeah. that's
To
what
do
it's
what?
coloring
Like,
things.
when? How do you choose how big your angle is?
So
Your
excited.
object?
For the reflection.
Can I say the really like little?
There's all the little
What?
rules.
Yeah.
You have to
Like,
Like-
when it goes through the
You have to
focal
Okay,
point,
like
it's
either
supposed
link
to-
them or
Okay.
like scribble up them to make them right because they're.
Like,
Sorry, Sam.
for this, like,
But I've
my two
never-
angles are different. I think that's one. But, like, how do you decide how big your angle should be?
Oh, you need an
Reflect
object
it.
that's taller, that's why.
I don't even
Oh,
want
so
to
it
think
should
about
be like
chemistry.
up there.
Yeah, so
They
that
got
you,
really complex.
like for horizontal, you start at your object, hit the mirror, and bounce off through the focus. And then
No,
you
those are
start
easy.
at
like,
the radius,
I don't
hit the
know.
top of the object, and hit the mirror, and go back. And then here you would start at the object, go through the focus, and come off horizontally.
Hi, Josh.
Here, come draw one.
Oh gosh.
Josh, say hi.
Like math with the structures that are like.
Oh, hi, Josh.
Drawing these is hard for me,
How are you
so
doing? I'm
I
insane.
strongly
I have
recommend
split
that
head.
you use inches
Hi,
instead of
Josh.
centimeters just because
I
it
have
takes a bigger.
these.
All right, listen, everyone, support
Christina's
Christina in
drawing.
this endeavor. All right. Oh, are you kidding me?
Is
And-
this
Stop
practice
it.
problem too?
Yes.
Okay.
An object is, okay, so your mirror has a radius of curvature of 10 centimeters. How long is 10 centimeters? Like 10 actual centimeters.
4 inches.
Is,
It's about 4 inches.
Yes.
you could use centimeters because 10 inches is like massive.
So,
Well, no, use 10 inches just so you can see it. It'll be fun that way. So put it like right there on the 10 and I'll try to hold your pivot point still. Right. Okay, that's good. All right, so now pick the middle point there where our pivot point was.
I got it's about
And
10
draw a nice
centimeters.
straight line.
Is that good? It's not very curvy. Oh, how's it just so curvy? Not cool. Can I use your compass?
Here. It's Josh's pencil though, I think, because I stole it. Okay, so the radius curvature is 10 centimeters. The object is 3 centimeters away from it. So 3 inches in our case. Okay, so then you have to draw in the radius and the focal point. Yeah. Okay, I'm stealing this syringe until you guys
Oh,
are
thank
done
you.
with class. You're drawing next too. Okay, so she has her object. Now, if you have the radius of 10 centimeters, then you take 10 centimeters and draw your R.
But are you doing it in inches though?
Yes, we are doing it in inches. Right, and she got the focal point as well.
Can I make it 5 centimeters? I'm just saying.
Why is
No, you have to
thing
make it
so
10.
big?
Because it's 10 inches.
Can't I just say that it's
Half.
half of this one?
Could you say it?
Take up a ton of space.
I know, it takes a whole sideways piece of paper to do 10 centimeters.
so
Well,
like
not
our
really. I
test?
mean, it just takes that much, but I already didn't measure.
Is that the
it.
10 or the 5?
That's, well, this is 5 right here.
So we're gonna have like a million pieces of paper for our test.
Pretty much.
There are about 6 of them. So you did 5.
Yeah.
Like each piece of paper.
So see how it'll be curvier than that?
Yeah. Okay.
So that your thing won't bounce right if it's not, you know. Okay,
Oh,
so
gotcha.
where's Christina's first line going to be, Nick? And here, we'll give her a new color.
Wait,
I know,
wait, hold
I
on.
know, I know.
Oh, he's green. You can pick any of the 3
Project
lines.
is placed 3 centimeters away, so that means.
You mean right now?
Okay, so you want a horizontal from the top of the object.
See the object now. Listen.
So the beam of light comes in, hits the mirror, and it won't go necessarily behind the mirror unless you think you're gonna have a virtual image.
I don't know.
Well, it won't be like that anyway, because what happens when it hits the mirror?
It reflects
Oh,
It reflects where?
to the focal point.
Through the focal point. So it'll go from the point where it hits the mirror through the focal point. Because light never passes through a mirror, but you might have to extrapolate lines through the mirror because. Okay, so that's your first line. Now you change color and somebody will tell you your second line. Matt, Josh, you know your next.
Can we just do it from like a horizontal line, like anywhere underneath it?
Nope. There are 2 more lines that you must draw to find your
So
object.
you go from the top of the object.
Well, then
No,
you.
because no, that's from here.
Well, then
Take
you.
from the object.
No, but
Top
the
of it
focal
is
point's
two.
behind it.
Uh-huh.
So
From
So,
the
like,
radius.
still pass.
The one that goes through the radius and
Okay, well, the
the.
radius is easy, so go ahead and do that
isn't it
one.
the third step though?
Well, but you
Does
can
it really
draw
matter?
three lines.
Matter.
Oh,
Well, I
but
thought there was
from
supposed
the
to be
radius
lines.
to the object to the
What?
mirror.
I don't
Never
think it
did the
matters
order
because
right.
they all just become lines.
Yeah, they're all just lines. It doesn't matter the order.
And then try extra.
So
No, not yet. Just see if you need to. But here, take that line further because it hits the mirror and is reflected straight back along that line.
Okay.
So, hold on.
But doesn't it go down or straight or something?
It goes, any beam of light that passes through the radius hits the mirror and returns on the same path. That's the rule. Okay, so then you're gonna have one that goes from the focal point to the object, hits the mirror, and is reflected horizontally. So from the focal point to the object, hits the mirror, and is reflected horizontally.
Wow, this is the prettiest color blue.
Or sweater. Okay, so now where are all those lines gonna meet? Are these three lines ever gonna meet?
Yeah.
No, but these
No.
ones will.
Right, so you're gonna have to extrapolate. So
Mine
what kind
don't
of
look like they're
image
ever
are we
gonna
gonna have
meet.
if we have to extrapolate the lines?
You must have drawn it wrong.
Oh no.
I do it on compass,
You hate when that happens.
I guess.
No, it's right. It's good, it's right.
We'll meet eventually. One day.
No, I didn't know we had to use a compass. So
Yes, it's
it
I
never
didn't
said-
either.
it never said
No,
anywhere in there.
no.
And I
My
was like-
physics teacher, who was the best teacher I ever had, truly, somehow either I was too not listening or he never actually said that. But you seriously have to use a compass or these things don't work. All right, so you extrapolate your lines. So
Wait,
here.
I
okay,
just
can
guesstimated.
extrapolate
Maybe
this?
I didn't make
That's what I
maybe
did.
I
I was
didn't
like,
make my
I did.
my
Oh, go ahead, sit down,
object
I'll tell
big
you.
enough.
It
That
could be.
an issue.
A big object helps, but it
How
shouldn't be
big does
too
the
big.
object have to be?
It's
'Cause
like-
30
does it
feet
ever
tall.
It
does
doesn't
ever-
really matter. It has to be something. It can't be nothing. So watch when I
Oh
extrapolate.
look, it's working!
Yeah.
Yay!
When
Yay.
you draw your lines, you want to extrapolate the line that bounces off the mirror. So here's the line that's leaving the mirror, so I'm going to extrapolate that line. And then the line, the purple line that leaves the mirror, yeah, you do the green one.
Look, it
leaves
worked!
the mirror.
And
And then the purple line that leaves the mirror here. And they're all going to meet somewhere right around here-ish, right?
If
So-
our pictures aren't exact, are you gonna take off points on the test?
As long as
Yes.
you get the right answer, like real or virtual.
Yeah.
So is this real or virtual?
She's gonna measure it down to the
Virtual.
little
Anytime
millimeters.
you have to extrapolate your lines, it's virtual. That's the rule. If you extrapolate, it's a virtual image.
Magnified.
Is it? Yep, it's magnified because it's bigger than your original object. And is it inverted or upright?
Upright.
Upright.
I got this one right.
I think I did too.
I got it right too.
Wait, which one was this?
Number 2.
Yes.
And I mean, it's possible that you could figure out how to do this without a compass, but I haven't figured that out yet.
It's a 50-50 chance, I think.
Well, like, at
Maybe
least
not
for
even
the-
as good as that.
Well, so far I've got 2 out of 5 wrong, so that's
Wait.
60%.
Well, your
right.
chance might be better than mine because my drawings are just naturally going to be like, and yours might actually have some scale to them because you pay attention to that, and I don't, unless I use a ruler. Who would like to draw?
Well, I'm writing them down.
I'll try next. Can I try?
Okay, yes,
I actually kind of want to do it
we have
too.
lots of these. Okay, so this is a convex mirror. So what's the difference between concave and convex?
It goes the other way.
Okay, so
I
concave
got
looks
this
like a
one wrong.
cave. You can go in the cave, right? Go into the cave. Convex
If you're small
is the other way. So it doesn't really matter which way you draw it. Like we keep drawing concave this way, so you could draw convex that way, or you could just use the other side of it. But so this mirror is
I'm going to
a
the
6, in your case, inch radius. So all those are pivot points for you, so that makes it a lot easier. And then, so put the marker there and go up and down and all around, so you make a circle. Push yourself. And then back down.
Gosh, look how big these things are.
Are you doing mixture still?
Centimeters or inches?
centimeters.
I'm not doing a good job of holding it still. Okay. Oh, good idea.
Your compass, it should have like a little scale to say
So
how
my
big
radius
the
is like
circle
right
is.
there-ish.
This is
So you'll draw your straight line.
But
like
look on
It
it, there
does.
should be
right
like,
there.
so you don't have to use your
A little
ruler.
higher, maybe, because that's.
You know it's
kind of
not
where
Christmas,
the
right?
started.
What?
But back here though, since it's calm.
So?
Yes.
I got actually.
Uh-oh, now we're in trouble, because we had to draw backward for me.
Really? It's still.
Oh wait, we have to draw it backwards.
Hey, can I see that back for a second?
Wait, how do we
you-
draw it backwards? We just go to
There
the
you
other
go.
side?
You just draw it the other way.
Draw the mirror backwards.
Well, yes, we could draw the mirror backwards,
You
but
look
since
like
we
an
drew it this
eyeball.
way, we're just gonna do it the same. Alright, so your radius is 6 inches, so draw a 6-inch,
Like that?
like, fake radius, I guess.
6 meter
Like,
radius.
you'll have, where's my thing? I
It looks
actually
like one of
wanna
those
see this
grabby arms, like those things that you pull the trigger and it goes.
I've never
Look
had
at
one.
it.
You gotta draw the little
Oh,
handle
yeah.
for it.
Oh,
yeah.
I just drew
With
this
the
yesterday too
dinosaur
because I'm
head
so
thing.
bad at this. So number 3, you're gonna put your radius and your focal point in there, because that's where they actually are. They're inside the circle, just like in a concave
Oh,
mirror,
why
they're
do you do this
inside
way?
the circle.
Okay.
I should probably do this one.
How many centimeters away is the radius? Or
The radius is 6 centimeters, so the focus is where? Your radius is 6, your focus is 3, because the focus is half. Yep, 6 inches, and it's to the inside of the circle because obviously a radius of a circle is measured from inside the circle.
And the
Do you have
object is
And then
right
put your
here?
Focus at the 3.
Do you have any more
Compasses, I might.
And the object is at 5?
I
I'm
can't see
so
my
dumb I
paper,
didn't
it's
even
too
bring
far
mine.
I did my
Sorry.
I did the third one completely wrong.
Okay.
I have Miss Mathias,
So,
I have
yes.
like this whole like case full of compasses.
Compasses.
And I forgot to bring mine.
All of my compasses break.
Yeah, the
And
object
we
is
have
at
good
5
ones,
centimeters.
but
I
they're
have
all
like I
broken.
have like a plastic.
I think my other one's.
My brother has like fancy
Mine
one, but he
metal
took
ones.
it to college with him.
Yeah,
I always put holes in the middle, like when I was
The
doing
paper?
grass
Yeah.
and trig, I'd always get holes in the center.
You take trigonometry?
I've broken
I did
so many
some.
compasses, it's just sad here.
Oh my gosh.
So right there.
And I did not really do math this year.
You're doing business math
Oh,
next year.
yeah.
Oh, me too!
No, I mean at home.
What is business math? Is that like
Yeah.
adding up the stuff to cash register?
It's like, no,
It's
it's
like
apple
getting a
plus
high
two
school
apples
credit so
equal-
you can finish and go to college.
exactly. But it's like accounting. I think that's what like
Well,
business
it's pretty much
accounting,
balancing
or,
a
like,
checkbook.
Balancing a
Yeah.
checkbook.
Alright, I don't have
There's
another
one at the
compass.
Potter school.
I have some
My
of
brother
those.
said it was basically
Okay,
like
so
having
Nick
a
has his
divisional.
object here at 5 centimeters. Alright, so where's its first line gonna go?
It's gonna go from
Oh, I
the,
set this up completely
from
wrong
the
on my
image,
paper.
or no,
Did you
from
do
the
the-
focal point
Usually convex or
through the
whatever.
image.
Yeah.
Wait, what?
I did the same thing when I flipped
They're
the
on the
mirror and left
in-
the points out.
oh.
Right,
I
because
did.
that's the mirror. Okay, the radius is always at the center of a circle. So when you draw a concave mirror, that seems intuitive, but when you draw a convex mirror, it doesn't seem intuitive. Okay, so the first one you're gonna do is if it hits the mirror parallel. So pick a color here.
What about this?
So draw your first one. Okay, so if it goes and hits the mirror horizontally, then it will be reflected back through what?
The focal point.
Right. So it's gonna hit the mirror like that and bounce off through the focal point.
What?
Can't go over the compass real
Well, you have to hit that spot too. Where it hits in the focal point.
quick. Just do it.
Yeah, and then. Okay, so put your
These are
arrows
so
too, so you know
confusing.
it went that way and then out that way.
What?
It takes a
How
lot of
is this gonna
practice.
help us with life?
oh, this
If
way.
you go into
so much
optics.
slow.
Who's going to optics? Raise your hand.
You wanna be an eye doctor, you
No, I
wanna
don't.
be a cell biologist, you need to fix your microscope. Okay, so Nick's second line is going to do
You want to
what?
work on the Hubble
Wait,
Space Telescope?
and then it,
Yeah,
how
seriously.
does, that goes up from the
What?
focal point?
The Hubble Space
Yeah,
Telescope.
just don't
this
count
this
it.
line passes.
Did you hear about
hits
like they
the
put up
mirror
in
through
orbit
focal
and then the
point.
pictures were
So
coming
what
out on
if
the
the beam of light
So they had
hits
to
the
like
mirror
go
as
and
if
fix
it were
it.
to
The
pass
mirror
through the
was like
focal
a
point?
50th of an inch off. So they had to grind like a 50 of an inch
So you
off
aim
it.
from the
That's
object.
50?
So this beam of light happens to be hitting the object and the focal point. So
And it was like
draw that
causing
line
light
from the
years of
object to the
difference in
mirror.
the proportion of the pictures.
Did you guys hear about in
and draw it
Ohio?
out. Now
someone
where is this
shooting
red line
movies?
gonna bounce? If it goes from the object to the focal point, where is it gonna reflect?
Along the floor.
Okay, parallel. So Nick will draw a parallel line there. Okay. And then, what happens if the beam is passing through the radius?
Goes back.
Okay, it just goes right back, so a purple line right there. It hits the mirror. And
Where
it
is it?
bounces right back. Okay, so now, arrow,
Wait, what?
because that line is passing through the radius.
Where's the one that I just did?
Is this the third one?
That's the
Oh,
third.
I did it back.
So
I
focus, parallel.
You do it on the
Radius
wrong
straight
side.
back. Yes, it's hard for me to do it the different way than I usually do it, but we can do it, it's possible. So are these three beams of light going to intersect each other? No, so we're gonna have a virtual image, right? So Nick's gonna extrapolate his three reflected lines. but you
Wait,
only
where's the
extrapolate
third one
reflected lines.
from?
Which color?
Is it perpendicular?
The red one hits the object and passes through the focus. So when it hits the mirror, it's like as if it were going to pass through the focus.
I think I just.
But you.
What's the purple? I'm so confused.
The purple
Miss
line
Elias.
goes from the object through the radius and reflects straight back.
But don't you
Oh.
extrapolate the reflected line?
You extrapolate the reflected line.
So the red line would be parallel.
the red line is parallel.
Okay, so
The purple line is along the radius line. And the green line is through the focal point. So Nick gets an image that is where? Okay, so we know it's virtual because we had to extrapolate.
Okay, I got it now. I don't like this one.
And is it reduced or enlarged? Reduced. And is it upright or inverted? Upright, thank you, Nick. Okay.
oh man.
They intersect.
Let me
on
see if that's
mine.
what I actually got.
They sort of
Virtual,
intersect on
upright,
You did it wrong.
reduce. Virtual,
I
upright,
did
reduce.
mine
Good, we
wrong
can do it.
again.
Virtual
I did it right.
All right, who wants to draw next?
I
Which
will.
Oh
one are we
wait, next
doing?
problem is not drawing. We're actually gonna do lots of problems today,
Or we just
so we
like
can do lots
make
of
up some?
lab
Josh, you're up.
next week. He's like, no. Question 4 doesn't involve any drawing, Josh. It's not that hard.
Well, they don't all three intersect. Two of them intersect and the other two intersect.
No, they really do intersect right there, perfectly.
Did just did it.
If
Oh, I
you
thought
do
you
it
said
right.
she didn't intersect.
No, see this reflected line, that reflected line, and that reflected line.
Oh,
Intersect
that's
real
nice.
happily right there.
Then I can say that they all sort of
Happily ever after.
generally in that general area.
Okay, so question number 4 involves Snell's law. And what does Snell's law tell us?
I didn't read that far.
we haven't.
Oh, we didn't read that
only
part.
got to number
Well,
3.
then Snell's law tells us, is it sine theta? I'll have to look. Yes. Okay, so this is Snell's law. It tells you that the index of refraction, which is n is not moles anymore, it's the index of refraction. Okay, so what's refraction, since y'all didn't read that far, okay?
Process by which a light ray bends when it encounters a new medium.
Okay, so I have a boiling flask someplace, right? Well, even this. Okay, so I have my beverage here, right? And I have a laser. Where's my laser?
Right there.
Laser.
Okay, so when a light beam, and laser is, of course, a light beam. So watch your eyes until we figure out where this is actually going.
Oh gosh.
Okay, so I'm going to hit a target on the wall over here where it's safe, right? That is a
That's a
flashlight, who
flashlight.
knew? Okay.
Wait, what did you do?
I just want to pick a happy spot on the wall where we can notice. Hold on. I will put a dot here and aim for it. Okay. So Snell's law tells me that light bends when the medium changes. So I'm going to attempt to not move flashlight. I'm going to try not to move the laser, which is really hard. But then when it passes through this, see how it bends?
That's
So why does the light bend when it passes through a different medium?
Because the
It
wavelength
expands.
is smaller, so it has to bend and keep the wavelength in line.
Okay, well,
Like this picture thing.
does light change speed in different mediums?
Yes.
Yes, light changes speed in different mediums. So when it passes through air, it's traveling one speed. When it passes through my beverage, it's traveling another speed. So the n is the index of refraction comparing this medium and the angle to that medium and the angle. So the index of refraction, n, in air is what? The book tells you. I should.
1.00.
It is. Index of refraction, I think, is unitless, right? Unitless? Anybody?
I think so.
It is. And the index of refraction is unitless.
What
What?
page is this on?
I don't even know.
401.
The
and
next page
402.
after you stopped reading this, Steve.
Yeah, 401.
Okay, so number 4 is really easy. This is not difficult stuff. Light traveling in air is incident on a block of ice. Hopefully it's clear and can pass through. Colorless. N of ice is 1.31. Okay, unitless. At an angle of 25 degrees. So theta ice equals 25 degrees. What is the angle of refraction? So we know that the first medium is air. We know n of air, right? 1.00, because the book tells us that. And we know, do we know theta of air?
That's what you
Well,
find
yeah,
out.
oh, you're right. This is, because that's the incident angle in the air, 25 degrees. So sine of 25 degrees equals N2, which is the index of refraction of ice, which is 1.31, times the sine of the angle we want to find out. What angle is it going to exit the ice? So, if you plug that into your calculator, what do you get? Calculate away.
My phone.
Easy stuff.
Which one are we plugging in?
We're trying to find it for air.
This. You're trying to find theta here.
19.1
So, if you
degrees.
do, well, 1 times the sine of 25 is just the sine of 25. Oops, that's
Oh wait,
not
no,
it.
never mind. Hang on. I forgot about the sign.
And then you divide
I got
by 1.31.
I didn't get rid
Well,
of the sign.
Sine of theta is 0.332. So how do you find
19.1.
theta? Well, inverse of sine. So second sine, or however your calculator does it. And I can have 2 significant figures.
Oh, okay.
So every
18.8.
2 significant
Oh,
figures.
19. Yes.
Okay. So make
So-
sure that you get 19 out of your calculator and you're able to do that. And
Wait, are we always going to use that, or is that just an example?
this is, I mean, sometimes you might have both thetas and want to find the index of refraction.
Oh, is
In
it just a
fact,
random?
you can use this equation any which way. You can
Okay.
find one of the variables if you know the other 3. And hopefully next week we're going to try to find the index of refraction of some piece of kitchen equipment
What
or
was the answer?
something.
19.
Do you even need to do the
Okay.
Yeah,
sign?
that's
Because
fine.
I got the same answer both ways.
This is 18.
If
I don't
like,
know.
erase the sign, if you just do 25 degrees divided by 1.31, it still gets you 19.
I wonder if that's dumb luck.
Maybe this is like the only possible combination of numbers that
I don't know. We can try it with a different one. I've never actually tried it that way because I'm a big rule follower. Okay, can everybody do this on your calculator?
Josh has none.
I just did, but I deleted it.
I got 18.8.
Yeah, same.
Right, so it's 2 significant figures souped around.
I got 19.1. How are we getting this different answer?
What did you get?
19.1.
I got 18.8.
And they're both rounded 19, but I'm off by
Yeah,
0.3.
I'm thinking it's probably just unfortunate luck. He should have checked his problem better.
And then equals
So you want to
You
divide
have
by
unfortunate luck, Josh,
1.31.
I'm sorry.
Well, no, like when
Is
I
that
do the
calculated
sign, when I
in
even do
right?
the sign and then
What do you
do
get for
the
a sine of
Whatever.
25?
Oh, you don't wanna
Whatever
do
one it
that.
works for.
sine 25 is 0.4226182617
All everything before the 1.3.
Now what do you get divided by
Yeah, delete the
1.31?
sign.
divided by
Yeah, not
1.31
delete the
equals
sign.
Because I got this negative.
0.3226.
Clear?
0.9361.
Clears everything.
Yes.
Or don't hit
And
clear.
then
How do you
Inverted
sign-
sign
inverse
times
sign
answer.
of the
Delete,
answer?
delete.
Eight. Hey, I
There's a
get.
delete button right here by the.
I did that
18.8.
exactly the same way I did last time and got a different
That's
answer.
right.
I pushed exactly the
Okay.
same buttons.
So erase the multiply.
See if your
sign.
calculator's faulty.
And then just find the answer to that.
But now I'm getting 18.8,
Okay,
so it's
so
still 19.
that is
So you
right,
add it
because
to that,
that's the sign
add
of
it,
theta, so you have to find the
there.
inverse sign of that.
Yeah.
Okay, so
So second
So
sign
then you
of
go.
that answer, can you get the answer to just reappear magically?
Yes, especially when like this long.
Oh, I can
complicated
just
thing.
do
It's
this.
like at the very end, you're like,
I can go.
Yeah, hit the inverse sign of that thing.
Lord.
What we do is 5 plus 6x squared.
Or just hit inverse sign and type it in.
That's a big one.
It's 0.3226, so inverse sign 0.3226.
Oh, inverse. Point 3.
226. Close parentheses and hit equal.
Oh, it's because it's closed.
Yeah, so 18.8. So you have to round it 2 significant figures, so it's 19 degrees. So that's how you do number 4. Index of refraction is really, really easy.
Yeah.
Okay. So you don't want my beverage to get in the way of your experiment, or else it'll bend your light beam and you won't hit your target. Okay, number 5. When light travels through a substance and encounters another substance with a lower index of refraction, there are some angles of incidence for which refraction is not possible. This is the most horrible problem of the year, honestly. I had to look at the answer book because I just could not figure this out. So anyone who gets it gets big congratulations. Pay attention.
Which problem?
Number 5 of the practice problems. Horrible, nightmare problem. For some angles, light is totally reflected back into the first substance. So what it's saying here is that if light travels through a substance and encounters something with a lower index of refraction, so like everything practically has a higher index of refraction than air, right? Air is 1. This is higher than 1, definitely. So if you found something that was lower than 1, or if I exited this into air, then I would be going to a lower index of refraction. There would be some angles for which it was internally reflected, completely reflected back. Nothing could pass through. So that would be an extreme angle and almost never happen in this case. But let's see. This phenomena is called total internal reflection. Consider light traveling in glass, which has an N of 1.5, and then encountering air. So let's say that was a glass window, and the light was in the glass window and then it encountered air. You'd have a big decrease in the index of refraction, right? So angles of incidence ranging from theta, I don't know what theta TR is, I can't see that.
Total reflection.
Oh, to 90 degrees are totally reflected back into the glass. What is the angle of total reflection for this situation? So it says, hence, solve Snell's law, which is n1 sine theta 1 equals n2 sine theta 2. So
It would
index
be,
reflection.
wouldn't it be whenever it's 1.5 times the sine equals greater than 1? Because sine of 0
Well, we need
is
a
0, and then,
You're right.
so what would that be? Point.
One divided by 1.5 inverse sine.
So it would be 42 degrees?
Yes, I'm so glad you got that problem in 3.5 seconds. Thank you. That's it.
Cool.
I'm glad that was obvious to everybody but me. I just thought about this problem my first year. So, anyhow, anything between 42 degrees and 90 degrees would be totally reflected. So if you have, like you know how they make windows that you can see through one way?
Oh yeah, the
Things
nursery
like that.
ones.
Yes.
Oh yeah.
Yeah.
Things like that might
Those are so cool.
have something like this, and in fact, there might even be something kind of like this.
Like the mirror ones, like where it's a mirror on one side.
Yeah.
Yeah.
And I am right now going to
Like
look at a
there's
copy
this
of your
porta
test
potty
because
that
I
you
think
can
there's
see
a
out,
confusing
but no
moment.
one can see in.
A porter
Potty.
potty.
That would
Oh,
that
yeah,
wouldn't work.
No,
Ours
Hey
is
guys.
just
No,
You guys, not the opposite way.
Oh god.
You are
'Cause-
completely
That would be
safe. There is
horrible.
nothing horrible on your test such as that.
Or make it so it's like only the back, so when you walk in, you
Alright.
realize it.
Oh gosh. That would be horrible.
Okay. Oh, I was not listening entirely. Okay. So, yep, that's problem number 5.
Wait, that was it?
Yep.
Oh, I said it was awful.
I thought it was
Wait,
awful.
how did you know? Are there actually?
Well, how
porta
did you
potties
know
that-
to use one?
Yeah.
Tell everybody, Josh, how you knew to use one.
because it says at the
Okay,
bottom.
attention.
Remember, the sine of an angle can never exceed 1.
Okay, so he just did an inequality saying that the index of refraction 1.5 of the glass times the sine of theta cannot be greater than 1.
Because sine of 90 is 1, and then after that it just gets smaller. So.
Right. So you can think about that on your own a bit, but there is no test question like that. No inequalities on this test. Number 6, the index of refraction for ethyl alcohol is 1.4. What is the speed of light in ethyl alcohol? So you have another equation that's really, really easy. The index of refraction is the speed of light for real, which we use as this, divided by the actual velocity of light at the moment, okay? So index of refraction is the real speed of light divided by the velocity of the speed of light in that particular medium. So if N of ethyl alcohol is 1.4 and you want to find the real velocity of light, then you can just rearrange this equation to be velocity equals the real speed of light divided by the index of refraction. So 3.0 times 10 to the 8th divided by the index of refraction gives you the actual velocity of light in alcohol, which is what?
2.1 times 10 to the
8, I hope.
8, yeah.
Not meters per 8. So light significantly slows down in ethyl alcohol, but we're also using not nearly enough significant digits for light, so you know. That's kind of, But easy, just memorize this equation. I should write you guys an equation list, or write your own equation list for this. Because really all you have in this module are doing those drawings, Snell's law, which is, maybe I'll just do it. N1 sine of theta equals N2 sine of theta, where N is the index of refraction, and then you have the index of refraction is the speed of light, c, divided by the true velocity of light in that medium.
Are those the only ones we have to know for this test?
I do think that that is all you've got in this module.
And remember your compass.
Use a
Yeah.
compass.
Or
Get a
maybe I'll the
compass,
same
use a
answer.
compass. Yep, that's about it. Looking at the test, I'm not seeing any other equations. All right, so then you have to learn how to do, well, everyone look at number 7 real fast, and we'll do a couple more drawings, and then you'll pretty well know everything there is to know about this, and you can aim for your mirror. How much time do we have? A while,
30
right?
minutes.
Time do we get out?
150. You got half an
Ah,
hour.
great.
150.
We can fill up as much time as humanly possible here, but number 7 says light is traveling in a special kind of glass called flint glass. If it encounters air at an angle of incidence of 20.1 degrees and refracts at 35.7 degrees, what is the angle of refraction? Oh, the index of refraction. So what's N for the flint glass? Okay, so which angle goes with which medium? That's the key to this problem. Okay. So we've got N of flint, N of air, angle of flint, angle of air, and what happens? Okay, so we want to find the index of refraction of flint glass, that's this. We know N of air is this. So which angle goes with the flint and which angle goes with the air?
20.1 would be the flint.
Yes, because it's already in the flint, so the first angle would be the flint. And 35.7 is the refraction when it exits the flint and enters the air. So then we just set up Snell's law. And we keep air together and flint together. So if flint is N1, we'll have N flint times sine 20.1 equals N air times sine 35.7. So what is the index of refraction of flint?
1.70.
Everybody else solve it and tell me if you get the same.
What was the answer?
What your
1.70.
calculator says. Yep, that's it. Get it?
I got 1.70.
Yep. Because you have to go to 3 significant figures.
698.
Christina, you've got it.
I got it.
Josh had it.
Well,
Take your time.
0.
Yes, because you have to round. So just take,
where's it?
You don't put
look at
N1
the
in
board.
Oh.
Take 1 times the sine of 35.7. So obviously you don't need the 1 because it's just multiplying.
Sine.
So the sine of 35.7. And then if you look at the other side of the equation, to get n of flint by itself, you just divide by the sine of 20.1.
This is why I don't have that. Why I feel like I just do all my work on a calculator.
I know, but you have to write down the steps.
Well, at least like.
Because if you type
Got
it
it.
in wrong, I can't give you partial credit.
Well, these.
I got it.
Not that you ever do that, but someday it could happen.
These problems
I
are
got
a
it.
lot shorter than the others, so it's not like you have to write out
I
a
know.
whole bunch
I
of.
still storm in there.
Okay, so now we have to deal with lenses. The drawing the light ray tracing drawings for lenses is pretty similar to mirrors. You have 2 types of lenses. You have converging and diverging lenses. So a converging lens would be like a convex lens, and a diverging lens would be like a concave lens, okay? When light passes, if that went right through the middle, it would be really cool. When light passes through one of these, it converges to the focal point, wherever the focal point is. And here, when light passes through this type of lens, it diverges straight and out. Okay, it diverges, and you could trace back to a focal point. Okay? So, converging lens, diverging lens.
Yes.
When you do the ray tracing diagrams, you don't have to worry so much about using a compass on these, only for the mirrors. Okay, so it's a little easier in that respect. So basically what I do to draw these things is I just make a nice straight x-axis and I make a nice straight y-axis for each problem. And that's nice and easy. Okay, so for number 8, who would like to draw?
Josh, you're up.
8
Alright, so this is a converging lens. So is my converging lens going to look like this or like
No.
this?
Yeah, the first one.
This. Okay, so Josh, I'll even draw your lens for you. It's not that hard.
There, look, Josh, she's doing half of it for you. Come on up here.
You can do it. Drawing these drawings is not that difficult.
Josh, come on.
Hurry up.
Josh!
Zoom, I'll tell you what to draw. You just come and draw.
Oh, great.
Okay, this is a converging lens with focal points that are 12 centimeters from the center. So now here's the thing. The difference between lenses and mirrors, obviously, is that a mirror reflects all light and a lens lets sunlight pass through, almost all, usually, right? A good lens.
Unless there's a glare.
Okay, so a lens will have 2 focal points, okay, instead of 1 like a mirror. So 12 inches. So you're going to draw a focal point at the 12-inch mark, so right there.
Here?
Mhm.
Up? Straight up?
Just a dot. Focal point, not an object. And then, of course, here at the 24, you'll draw that. That's the other focal point. 2 focal points since light can pass through. Okay, now label them with, well, here, draw that line long enough that it passes it.
Oh, this one.
Okay, and label your 2 dots with 2 lowercase f's because they are the focal points. Okay. An observer looks through the lens at an object 3 centimeters from the lens. So how does that image appear? Okay. So
I see the
the key
vibration
about
thing on the
lenses
edge.
is don't use the edge of the lens. Use the middle line in the middle of the lens. Okay, your y-axis. Use your y-axis to do measurements. So it says 3 centimeters. So you draw your object right there, 3 centimeters from the center of the lens.
So,
Right there. Straight up arrow. Okay, so we're looking at this object, right? So then you have your set of rules for drawing these things for lenses. And that's all the information we have. So, now here's where it gets tricky. With a lens, somebody get that list of rules for lenses out in front of them too, because that's
Is that 12 point?
one of those things I love to have. Okay, for a converging lens, the lens has to be very thin. That's why we don't even consider the outside of the lens. We only consider the y-axis. You measure all distances from there. And they are also subject to spherical aberration, just as a side note. So if you enter the lens horizontally, you exit through the focus on the other side. Okay, so take one color that's not purple.
go ahead.
And you're going to enter the lens horizontally, so from the object horizontally to that middle line.
This one right there.
Yep, right there.
There.
Right. So
So
draw
do
your
an
little
arrow?
arrow, yeah. Okay, so this is a converging lens. That means it's going to take all rays of light entering it and converge them toward their focus. This focus, okay? If light enters that way, it focuses toward this focus. So it's going to go right like that. So go ahead and draw that line in red.
Is it from here
From
to
there
there?
to the focus. All right. So draw your arrow. And the second rule says enter through the focus, exit horizontally. So if it enters through this focus right here,
And do the same thing as it did.
right. Well, it won't ever, the light beam will come that way, but it'll go to the middle. Like it's gonna hit right there in the middle
Oh,
of
so
the
draw.
fish. Right, yes. Oh, get a different color. I really like it when each line is a different color, because then I can figure out what's going on.
So draw from down here to.
Just from the object, even
Oh, so this thing right here.
Yeah.
too.
to the middle line, right there. Okay, now draw your arrow.
Oh no, I did it wrong.
Let me see if it's gonna be good. Okay, we're doing it right. And we exit horizontally. If it comes from
Different
the
color?
focus, we exit horizontally. No
Why?
green. This one's green still. Because the light beam is actually going into the lens. Now it's leaving the lens.
So it's that all the way.
Yes, straight. If it comes into the focus, it goes out horizontally.
Where do I stop?
Right there's
Just
one.
keep going.
Okay, so put your arrow.
Forever?
Yes.
Yes, light beams do go on forever unless they're absorbed by something.
Like
Forever.
It's like
forever and ever and ever.
Okay, so first we came in horizontally, we went out through this focus. We came in through this focus, we go out horizontally. So the last one is any beam of light that passes through the center of the lens, like the place where the X and Y
So
axes
it's gonna
meet.
go
comes straight, and it just
So
is
it goes from here down there.
right.
Black.
Sure. Black is good.
From right here down to like your finger.
Yeah. Okay.
Don't stop.
So. Did I do that right? It
Isn't
looks
the
like that
green one-
stuff is
Josh,
divergent,
first
but it has to be right.
We drew it wrong.
Isn't the
Josh, you messed it up.
I
It's
thought the
your
green
fault,
one-
Josh.
I thought the green one was supposed to go horizontally and
It came
No, the red
in
one
through
went
the
in
focus.
horizontally.
If it enters through the focus,
should
it
skip
exits
this module.
horizontally. We're not skipping this one. I think we're right. So what we would
visual
get,
rules.
assuming that we are right, and I'll draw all this stuff in a different color and we'll see what happens.
All light rays
Is-
that enter the lens and traveling horizontally will exit the lens traveling through the focal point. Do we have that?
Anything that
Yes.
enters horizontally exits through the focal point.
Good. All light rays that enter the lens traveling through the focal point will exit the lens horizontally.
Enter through the focal point, exit horizontally.
All light rays that enter the lens traveling directly towards the center will experience no deflection.
Directly
That
through the center, no deflection. Right where the X and Y axes cross. Okay, so.
Are they talking about the same focal point?
Are they talking about the same focal point? Well, here's the key to this. You have to think this is a converging lens. So everything that comes in should converge, right?
Oh yeah, because we're doing the ones that that are refracted, not the ones that started. So yeah, that works. Okay.
So if it comes in through the focal point, it comes in through it. But if it exits through a focal point, it literally has to exit through the other focal point. So
Isn't
you're
there supposed to be
using
a
one.
focal point on the other side too. that you
Yes,
use?
this is right here. This is a focal point, which we've erased because we've squished it. So it has two focal points. When it enters horizontally, it exits through the focal point that it's headed for, because this lens converges light toward its focal point. When it enters through this focal point, it exits horizontally. So you do use actually both focal points, one for horizontal and one
So
for.
where's the
entering.
image at? Is it the
Well,
one?
then the one that passes through the x-axis, so I extrapolated it, I extrapolated this straight parallel green line, and I extrapolated this slightly angled red line. And I think they all pretty well meet right about here. So, I have a magnified image that is upright and virtual because I had to extrapolate. Is that what I have on my answer sheet?
Wouldn't it be
Virtual,
real?
upright, magnified. No, because I extrapolated these lines.
Oh.
If I had to
That's weird.
extrapolate the
Well, it looks like it's on
refracted
the
lines.
same side.
It is on the same side,
And it's
but
behind where
when
the
you're
actual
looking through a
object.
lens, it's something.
Oh.
There's so many.
Isn't that so confusing? It's
That's
taken
why
me
we should
3
skip
years.
it.
Like, I've fumbled through this lesson for the last 2 years. This is the first year I feel like I actually could do this while people are trying to confuse me.
Is this your least favorite module?
Yep. And it's the one, chemists
skip it.
never, physics overlaps with chemistry and a lot of the other modules, but never. We never do this, not ever. I've never used lenses in real life for anything.
Be an eye doctor.
Yeah, if you want to be an eye doctor, keep studying.
No.
Or
with
a
someone
Hubble
else.
Space Telescope designer.
What are you gonna be?
This could
I don't know.
Work at
This could be in a
McDonald's.
nursery his whole life. That's what boys.
Okay,
Teaching
Number
them what the-
9.
teaching them how to
one of you
refract
ladies
the
needs
light.
to draw.
What? Your turn.
I
Christina
volunteer
already
Josh.
drew. Stephanie?
I guess I can do it.
Okay, so we have a
There, we have a
converging lens
volunteer.
again, which is the same.
I need to watch
I
it.
get the hard one.
Alright, so draw an X and Y axis first.
Yeah.
Yes, you're getting all your problems done. But do the extra practice problems too. Yeah, I know.
I also have to watch not one movie this year. I have to watch all 3 minutes of Star Wars.
Why?
For homework.
All 3 Star
The
Wars.
old ones.
Oh.
Which are the better?
Okay.
Yeah.
So So first thing
Why
you do
Star
with lenses
Wars?
is draw that X and Y axis. Got it? This is a converging lens, so you draw that same kind of thin, bubbly lens, but you don't really ever use it because you use that center line. So always use the center line, not the thing you just drew. Got it? Use the X and Y axis. Don't look at your lens. It just reminds you that it's a converging
Wait, so
lens.
for these, we don't really have to worry about the lens, more just the axis
You
itself?
use the axis. You never
Okay.
use the lens. So the
Just-
focal points are 8 centimeters, so we'll use 8 inches, just so people can see what we're doing. So, you're gonna draw one focal point, and then one way at the end, put on right on, and then one at the 16. Okay, and label that with lowercase f. All right. If an observer looks through the lens at an object that is 12 centimeters from the lens, so we'll put our object 12 inches. Yep, so draw an arrow. Okay, so that is our object.
Where's our object?
12 centimeters from the lens, right there.
Could it be on either side?
Could it be on the other side? It could. Then you have to do it all backward. Okay, so what's our first rule for lenses? First rule, guys. What's the first rule for the light ray? What's the first
Horizontal.
letter? So change color.
Horizontally.
Horizontal.
So you want it to enter the lens horizontally.
Go from the focal point?
Alright, make sure I'm actually horizontal there. And it'll move, you might want to hold it when it starts to. Sorry. Alright, so it'll hit the middle of this. If it goes in horizontally, then how does it go out?
Through the focal point.
And it goes out through which focal point?
The
The other
red
one.
one.
Yep, it's gonna converge toward this focal point. So we use that, the y-axis and the focal point. Okay. And then you put an arrow to show which direction that line's going. Then you change color. Okay, what's our second rule?
From when it goes
Does it
straight
go down
through the
It's on the
center.
outside.
There's another one.
It's on the side of the bag.
Oh, that's, oh it is. Okay, what's the next rule?
When it goes like straight through the center, there's no reflection. or-
Okay, so it just passes straight through the center point. And just keep going, because it will just pass right through that space. Okay, so it's looking good for us to have a real image, because it looks like they are gonna converge at some point. And what's the third rule, the hard one, I think?
If
Well,
it goes straight through the center, it doesn't diffract.
We
or
just
whatever.
did that one, that's this
Oh.
one.
But the focal point's in front of it, so.
Uh-huh, so our lens isn't actually drawn where it will
Oh.
pass. But if it,
Okay.
hold on, I'm gonna put you on top of it there. So if it goes through the object, through the focal point and hits the y-axis, then you stop. Okay, then it comes out horizontally. Sorry. Okay, so where are all these guys gonna converge?
Somewhere.
Right, somewhere, like this one should go there, there, so probably right there. So is this image real or virtual?
Real.
Thank you, Stephanie. It's a real image, because I didn't have to extrapolate lines.
Somewhere far down
Wait.
below.
Right, and is it, this is the image right here,
It's inverted.
inverted and
Bigger.
magnified.
How do you
Yes.
tell if to invert it or not?
It's just where these beams of light
Okay.
would intersect each other.
The bottom
Like the
stays on
arrow's
the
up
line,
at the start and
then
it's gonna be
top goes
down.
wherever the arrows are.
Right, it just, you can see that it's gonna be
That's how I
bigger than the first arrow used to be. That's why it's so important to make your drawing right, because, you know. So what did I get? I got real, inverted, and magnified. Yay, we did it right. That wasn't always the case for me. It's a big achievement today. All right, everyone good with that drawing?
Yep.
Stephanie is working to catch up with that.
All
All right, who hasn't drawn?
I have it.
Come on up. No drawing.
Be fun.
Thank you.
It's almost this way.
Yes.
No,
I have
I'm
that
not
job.
letting Josh draw.
So you done it?
Okay, so Andrea gets the diverging lens. So that's the one and only. Focal points are 8 centimeters, object is 5 centimeters. So, draw your X and Y axis first. And while we're on the Y axis, you can, sorry, possibly. Okay, so while we're there, you can draw 8-inch focal points. So go 8 that way. And then the object is 5 centimeters in the middle. And she's gonna give us a right-handed version of life today. That's okay. We have righties in this class too, y'all are. Alright, this is my true test of if I can do it or not, because it's the opposite way for me. Okay, so this is a diverging lens, so you're gonna draw like the hourglass. It doesn't have to be super huge, because you're gonna use the axis anyway. Alright, so we've got a diverging lens. Alright. Maybe make your object just a tiny bit taller since you've got,
What?
okay.
A unit
Now,
count?
we have everything we need. So what will pick a new color. What will my first line be?
Horizontal.
Alright, so he wants to enter the lens horizontally. And stop at the y-axis. Good. Okay, now what will this lens, go ahead, draw your arrow so you know it's in frame. What will this lens do to a beam of light? Is it going to converge it? Here, step aside so they can all see. Is it going to converge this lens through this focal point? No, this is a diverging lens. It's going to diverge it through that focal point. But go up. Yep, you go up. So you have to pay attention to which kind of lens you actually have. Okay, so then what's my next rule?
Go in pointing from the focal point. Or wait, no.
So if it goes
Towards the focal
in
point.
through the focal point,
It's gonna go out straight.
oh, pick a new, maybe you have a new color, okay. So straight to the y-axis, stop at the y-axis then. So, always stop at the y-axis, I know, I do. Okay, so
So
put your
this
arrow
one
there.
would.
And it'll exit how?
Horizontal.
It'll exit horizontally. And what else is true about all lenses?
The radius of curvature thing.
No radius on a lens, only
Oh,
focal
yeah.
points. Yeah, okay, so if it goes straight through the center, it's a straight line. So from the object straight on through.
Oh yeah, that.
So from the object straight through the center of the lens, and it just keeps going. Light passes right through the center. Okay, so where are these three lines gonna meet? Never, so we have to extrapolate them. So what kind of image are we gonna have?
Virtual.
A virtual image.
It's gonna be like halfway between the image
Alright,
and
thanks,
the
Andrea.
mirror. Or the lens.
Okay, you can extrapolate for me if you want.
I'll extrapolate.
Okay, so I'm gonna extrapolate this, and, well, hopefully somewhere they'll meet, like, right there, and give me an image here, which is it reduced or magnified,
Reduced and
Is it-
upright.
inverted or upright? Upright, so let's see if that's what I got. Reduced, virtual, upright, hooray.
I drew Mama.
I could just cry. Okay, so now you have 5 minutes to
I like
clear a
so
path
fun.
and hit the target. Here are 3 mirrors, so, oops. Alright. Yeah,
Anyone get pink?
hold on. You guys, let's see. Alright, somebody pair up with Josh, somebody pair up with Nick,
I got it.
and somebody pair up with Stephanie.
Do I have to?
I'm going to find my laser. Alright, your target is in here. On the wall.
It's always fun to do.
You have lots of rulers in that corner if you want to set up your angles, but I'm standing.
Are they normal mirrors or are
Is it
they?
that
They're
sheet of paper
normal
right here?
mirrors, flat
Never done
mirrors.
that
What?
before?
The sheet of paper.
Do you ever do that in the bathroom where you take one, like the
Yeah.
wall mirror, and then you
Yeah.
go, and you're like, ooh.
Alright,
And you
so
can see, like,
I'm
three
aimed
heads.
right here, so set up your mirrors.
Where are you aiming?
All right, here. One right here. Pick one.
Wait, you're aiming
Wait, we're bouncing off the.
three?
3 mirrors to
We
hit
only
the
need
target.
2.
What target are we trying to hit?
This piece of paper right here. You put yours right there on the wall.
Wait, where are you shining it?
Now
I'm
angle
gonna
it
hit
so
Nick
that
if
we
he
have the
doesn't
same
move
angle
before we start.
between from there to there and from here to here.
I'm hoping.
What do I do with mine?
Wait, we only get one shot?
No, I'll let you have a few other
Go
tries.
stand somewhere, Josh.
Where? We don't need it.
Let Josh tell
He
you.
doesn't think you're needed.
We only need 2.
Well,
Alright.
use the bigger one.
Well, you're
Alright,
gonna
here,
miss
toss
to
it.
begin
No,
with,
don't toss
'cause
it.
I'm not aiming for
Right
you.
here.
Catch, right?
Do you see where she's aiming? She's not aiming where you are.
Wait,
She's
aiming behind you, Matt.
aiming on your arm. Lower, lower,
I can't
lower,
see it.
lower, lower. Up! Don't blind me. Lower.